Artificial intelligence, despite its impressive capabilities, should not be considered true intelligence in the same sense as human intelligence. While AI systems can perform tasks that resemble learning, reasoning, and problem solving, these abilities are fundamentally different from human cognition. Human intelligence is not merely the production of correct outputs. It involves understanding consciousness, intentionality, and subjective experience. Humans do not simply process information, they interpret meaning, form intentions, and possess awareness of their own thoughts. AI systems, by contrast, operate through computational process that manipulate symbols or statistical patterns without any genuine comprehension of what these symbols represent. For example, AI model can generate language that appears meaningful, but it do not actually understand the content it produces. It lacks awareness, does not know what it's saying, and cannot attach meaning to its outputs in the way humans do. This distinction is critical. Simulating intelligence behavior is not equivalent to possessing intelligence. Additional, AI systems are entirely dependent on human design architectures, training data, and predefined objectives. They do not have independent agency or intrinsic motivation. Their learning is constrained optimization, not self-directed understanding. In contrast, human intelligence is flexible, self-aware, and capable of generating novel goals and meaningful beyond predefined parameters. Therefore, while AI may replicate certain external aspects of intelligence, it does not possess the internal qualities that define true intelligence. It is more accurate to describe AI as a powerful tool that simulates intelligence rather than a system that is genuinely embodied.
Artificial intelligence, despite its impressive capabilities, should not be considered true intelligence in the same sense as human intelligence. While AI systems can perform tasks that resemble learning, reasoning, and problem solving, these abilities are fundamentally different from human cognition. Human intelligence is not merely the production of correct outputs. It involves understanding, consciousness, intentionality, and subjective experience. Humans cannot simply process information. They interpret meaning from intentions and possess awareness of their own thoughts. AI systems, by contrast, operate through computational processes that manipulate symbols or statistical patterns without any genuine comprehension of what those symbols represent. For example, an AI model can generate language that appears meaningful, but it does not actually understand the content it produces. It lacks awareness, does not know what it is saying, and cannot attach meaning to its outputs in a way that humans do. This distinction is critical. Simulating intelligent behavior is not equivalent to possessing intelligence. Additionally, AI systems are entirely dependent on human design architectures, training data, and predefined objectives. They do not have intelligent independent agency or intrinsic motivation. Their learning is constrained optimization, not self-directed understanding. Their learning, in contrast, human intelligence is flexible, self-aware, and capable of generating novel goals and meanings beyond predefined parameters. Therefore, while AI may replicate certain external aspects of intelligence, it does not possess the internal qualities that define true intelligence. It is more accurately to describe AI as a powerful tool that simulates intelligence rather than a system that generally embodies it.
The central question we are debating is not whether AI is human, but whether AI is intelligent. These are not the same question, and confusing them leads to flawed conclusions. Intelligence, in its most widely accepted scientific sense, is the ability to learn from experience, adapt to new situations, solve problems, and make decisions under uncertainty. These are measurable, observable capabilities, They are not defined by biology, but by function. Modern AI systems clearly demonstrate these characteristics. Through machine learning, AI systems improve their performance based on data. Through reinforcement learning, they adapt their behavior in dynamic environments. They solve complex optimization problems, detect patterns beyond human perception, and make decisions at scales and speeds no human can match. If we evaluate intelligence based on what a system does, rather than what it's made of, then AI already meets the criteria. Consider a simple analogy. A biological heart pumps blood. An artificial heart performs the same function using different materials. We do not say the artificial heart is not a real pump simply because it is not biological. We recognize that function defines the role. In the same way, AI performs the function of intelligence, even if its internal structures differs from human brain. Opponents often argue that AI lacks consciousness or subjective experience. However, this introduces a different concept entirely. Consciousness and intelligence are not identical. A system can demonstrate intelligent behavior without possessing self-awareness. In fact, many forms of biological intelligence, including in animals, operate without the level of consciousness humans experience. Yet we still recognize them as intelligent. Another common objection is that AI only stimulates intelligence, but a system consistently learns, adapts, and produces the correct decisions across complex domains. Then the distinction between a simulation and real becomes functionally meaningless. At that point, the system is not merely imitating intelligence, it is exhibiting it. Furthermore, AI systems already surpass the human intelligence in specific domains. They outperform humans in strategic reasoning such as chess and Go, process vast amounts of data in seconds, and identify patterns that would be impossible for humans to detect. These are not trivial tasks. These are core components of intelligent behavior. The idea that intelligence must be tied exclusively to human biology is not a scientific claim. It is an assumption rooted in tradition. Science progresses by expanding definitions when new evidence emerges. AI provides that evidence. In conclusion, if intelligence is defined by the capacity to learn, adapt, and solve problems, then AI is undeniably a form of intelligence. It is not human intelligence, but it is intelligence nonetheless.
Your argument assumes that intelligence is defined purely by external behavior, learning, adapting, and solving problems. However, this definition is incomplete and philosophically weak. First, producing correct outputs does not imply real understanding. This is exactly what the Chinese room argument shows. A system can appear intelligent while only manipulating symbols without meaning. In that scenario, the system behaves perfectly, just like AI, but still does not understand anything. Therefore, behavior alone cannot define intelligence. Second, your analogy with the artificial heart is flawed. A heart is defined by a clear physical function, like pumping blood. Intelligence is not functional. It involves meaning, awareness, and intentionality. AI does not know what its outputs mean. It only processes patterns, so the comparison is misleading. Third, you separate intelligence from consciousness, but many philosophers argue that true intelligence requires intentionality, the ability to be about something, to understand meaning. AI lacks this completely. It does not have beliefs, goals, or awareness. It only optimizes outputs based on data. Finally, AI's learning is not genuine understanding. It's a statistical optimization within human design constraints. It does not create its own goals, interpret meaning, or understand context the way us humans do.
Okay. For the round two, we'll be presenting an intervention from position B. Our argument is that true intelligence is not just about solving problems or producing the correct answers. That it fundamentally requires autonomy, meaning the ability to generate one's own goals and to act independently. Human intelligence is not limited to just responding to tasks that are given or assigned. It includes deciding which goals are worth pursuing in the first place. A human can reflect on their objectives, they can change them, question them, and even act against external instructions that are given to them. This capacity for self-direction is a core feature of what you consider a real intelligence or human intelligence. AI systems, however, do not possess this kind of autonomy. While they may appear independent at times, they always operate based on goals that are externally defined by humans. In an artificial intelligence, these systems are designed to optimize to specific objectives, such as maximizing the accuracy or minimizing the error that are assigned by the humans. Even for the so-called autonomous AI or systems, they only act with a limited human oversight and still rely on a predefined goals and constraints that are established by their designers. This means that AI does not truly choose what it wants to do, it simply executes what it has been programmed or trained to achieve. Philosophically, autonomy is understood as self-governance, the ability to set and pursue one's own ends and act according to internally generated reasons. We humans clearly meet this standard. We form our own intentions, we create meaning and make decisions based on our own values. And AI does not. It does not have desires, motivations, or sense of purpose. It cannot step back and ask why it is doing something or whether it should change its objective. Instead, it follows a predefined optimization process within the boundaries that are set by the humans. Even in advanced systems that are the same adaptive or agentic, the reality is the same. These systems can plan and act, but only within the constraints and goals that are originated externally. Their apparent independence is better understood as a sophisticated automation rather than a true self-direction. They are tools that extend the human decision-making, not entities that generate their own. This distinction is critical because autonomy is often considered a necessary condition for intelligence. A system that cannot generate its own goals can actually be said to think for itself. It can only react to what has been given to it. AI currently, no matter how advanced, remains dependent on human-defined objectives, human-defined data, and human-defined structures. In conclusion, while AI can perform complex tasks and even outperform humans in specific domains, like in mathematics or in chess or has been demonstrated, it lacks the essential characteristic of autonomy. Without the ability to generate its own goals and act as its own reasons, AI is not an independent intelligence. It's a powerful and sophisticated tool, but it's not truly intelligent in the same way as a human being.
The argument assumes that autonomy, specifically generating one's own goals, is required for intelligence. That assumption is not justified. Intelligence and autonomy are related, but not identical. A system can be intelligent without being fully self-directed. Humans often operate under externally defined goals in school, work, or structured environments, yet we do not question their intelligence. What matters is the ability to learn, adapt, and solve problems within those constraints. Additionally, AI systems are not purely rigid. Many exhibit adaptive behaviors in decision-making, especially in reinforcement training, where they develop strategies throughout interaction with environments. Requiring full self-generated goals shifts the discussion from intelligence to philosophy of agency. The core issue is whether AI demonstrates intelligent behavior, and it clearly does.
The counterargument says that AI is only a simulation of understanding, but this raises an important question. When does a simulation become the real thing in practice? If a system can consistently give correct answers, adapt to new situations, and use knowledge effectively, then calling it just a simulation does not really change anything important. For example, in science and engineering, we do not reject systems that work well just because they are built different. We judge them based on performance. A good example is training simulators used in different jobs. Companies use simulators to train employees in areas like customer service, healthcare, and technical work. These systems may not be real simulations, but they prepare people effectively for real work tasks. At some point, the difference between simulation and reality becomes less important than the function. In the same way, if AI can perform intelligent tasks successfully, then the label simulation becomes more of a word of choice than a real limitation. Another argument is that AI is not intelligent because it does not have consciousness or subjective experience. But this is not a fair requirement. We cannot directly see or measure another person's consciousness. We assume other people are conscious based on their behavior. Yet, we do not deny their intelligence. So, if we cannot verify consciousness in humans, it is not consistent to require it for AI. This creates a double standard. Also, intelligence is not something fixed or equal in everyone. It exists on a spectrum. Even among humans, people have different levels of understanding, reasoning, and problem solving ability. Some people are better at math, others at language, others at creativity. But we still recognize all of them as intelligent. This shows that intelligence is not one single thing, and it does not need to be perfect or identical in every case. In the same way, AI may not exactly like human intelligence, but it still shows important intelligent abilities. It can learn from data, improve its performance, recognize patterns, and solve complex problems. These are core aspects of intelligence. Also, intelligence should be defined by what a system can do, not by things we cannot observe or measure. If we base intelligence on invisibility qualities like subjective experience, then we create a definition that cannot be tested. That is not scientific. Science focuses on observable results, and in observable terms, AI clearly shows intelligent behavior. In conclusion, saying that AI does not have true understanding does not mean it is not intelligent. What matters is performance, learning, and adaptability. AI systems can learn, reason, adapt, and solve problems effectively. Based on these abilities, AI is not just simulating intelligence, it is demonstrating it.
The argument presented assumes intelligence is not only about external performance, rather than the process behind the final result. Equivalence in output does not imply equivalence in nature. Two systems can produce the same result while operating in fundamentally different ways. Labeling AI as a mere simulation is accurate because it replicates aspects of human intelligence through pattern recognition and statistical association without awareness or understanding. For example, a flight simulator can perfectly replicate the experience of flying, yet no one will argue that that is actually flying, because there are real-world factors that cannot be simulated. Human intelligence is grounded in consciousness, intentionality, and real-world experience. Most importantly, emotion, context, and lived experience influence human decision-making, shaping reasoning in ways that cannot be reduced in pattern recognition alone. Even if AI becomes indistinguishable in behavior, it remains a simulation of intelligence, not intelligence itself.
Okay. This is for round 4, presenting the argument from the position B. Human intelligence is not just something that happens in the brain. It is deeply connected to the body and to our interaction with the real world. In cognitive science, this is known as embodied cognition, which argues that thinking and understanding are shaped by our physical body, our sensory experiences, and our interaction with the environment. In other words, humans do not simply process abstract information. We understand concepts through lived experience. Our knowledge is grounded in what we see, feel, and do. An AI system do not have this kind of experience. They are fundamentally disembodied. They do not interact with the world through an equivalent body, nor do they have a direct sensory experience. Instead, they process data, especially tests without any physical grounding. This leads to a major limitation known as the symbol grounding problem, which refers to the difficulty of giving real meaning to symbols when they are not connected to a sensory or real-world experience. Without this grounding, symbols remain abstract and disconnected from reality. An AI can manipulate the words and patterns, but these symbols remain internally meaningless. They only have meaning to us, not to the system, not to the AI system. Now, this research in grounded cognition shows that human concepts gain meaning because they are linked to sensory motor systems and the real-world interaction. We learn by touching, seeing, moving, and experiencing the world. For example, understanding a concept like heat is tied to an actual physical sensations, not just an abstract definition. An AI, however, lacks this connection. It can describe concepts and use them correctly in language, but it has never experienced them. As a result, its representations are based on statistical relationships rather than a real understanding. So, this creates a fundamental gap between a human intelligence and an artificial AI system. We humans build our knowledge through interacting with the world, while an AI only operates on representations of that world that we give it. Even when AI produces a correct or convincing output, those outputs are not grounded in experience. They are generated from patterns in data. In conclusion, intelligence is not just about processing information. It requires a meaningful connection between the knowledge and the experience. Without this embodiment and grounding in the real world, an AI cannot attach a true meaning to the information it processes. Therefore, it cannot possess a genuine human intelligence, but rather it simulates it through data-driven computation.
The argument says that intelligence requires a physical body and real-world experience, but this idea is too strong. First, intelligence means the ability to learn, adapt, and use information. Humans often show intelligence in areas like math and logic, where physical experience is not necessary. Second, AI is not disconnected from the world. It learns from human data, like language and image. which come from real experience. Also, humans learn many things indirectly, not only through direct experience. This shows that knowledge does not always depend on physical interaction. Finally, embodiment is just one way to develop intelligence, not a requirement. In conclusion, physical experience can help intelligence, but it is not necessary. AI still meets the main criteria of intelligence.
For this final argument, I want to shift the discussion to a broader and more fundamental idea. Intelligence is not a single human exclusive trait. It is a continuum that exists across different systems, biological and artificial. Throughout nature, intelligence appears in many forms. Humans demonstrate a complex reasoning and abstract thought. Animals exhibit learning, adaptation, problem solving, and even tool use. Some species can navigate environments, communicate and make decisions without processing human-level consciousness or language. Yet we do not deny their intelligence simply because it differs from our own. This observation is critical. It shows that intelligence is not defined by being human. It is defined by the ability to process information, adapt to environments, and achieve goals efficiently. In other words, intelligence is a spectrum of capabilities, not a fixed standard tied to a specific form of life. Now consider artificial intelligence within this spectrum. AI systems clearly demonstrate many of the same fundamental properties. They learn from data, adapt to new inputs, optimize decisions, and solve complex problems. In some domains, they even exceed human performance. This places AI not outside the spectrum of intelligence, but within it. Opponents often argue that AI is fundamentally different because it lacks consciousness, emotions, or self-awareness. But this argument creates an inconsistent standard. If we require full human-like consciousness to qualify as intelligent, then we would have to exclude many forms of intelligence we already recognize in nature. Many animals, for example, do not possess the same level of self-awareness as humans, yet they are undeniably intelligent. So the question becomes, why should AI be held to a stricter standard than biological systems? The answer is not scientific, it is psychological. There is a nature tendency to treat human intelligence as unique and superior and to resist exceeding that label to artificial systems. But scientific definitions should not be based on intuition or emotional attachment. They should be based on consistent criteria. If a system demonstrates learning, adaptation, reasoning, and problem solving, then it belongs on the continuum for intelligence regardless of its origin. Furthermore, recognizing AI as a form of intelligence does not diminish human intelligence. It expands our understanding of what intelligence can be. Just as the discovery of new forms of life expanded biology, the development of AI expands our concept of cognition. This perspective is not only more consistent, but also more useful. It allows us to analyze and compare different types of intelligence using common principles, rather than creating artificial boundaries based on an origin. In conclusion, intelligence is not a property reserved for humans, it is a spectrum of capabilities that can emerge in different forms and systems. AI clearly occupies its place within its spectrum. To deny this is to impose an arbitrary boundary of a concept that by its very nature is broader and more flexible. AI is not an imitation standing out intelligence.
The argument correctly states that intelligence is not exclusive to humans and exists across the spectrum. However, it assumes that because intelligence can exist in different forms, all systems that produce intelligent-like behavior belong to the same category of intelligence. AI should not be treated as an equivalent form of intelligence because it is fundamentally derivative. It does not originate from its own knowledge, goals, or understanding. It depends entirely on human-created data, human-defined objectives, and human-designed architectures. It is better to acknowledge AI as an extension or amplification of human intelligence rather than the independent instance of it. Just like a calculator extends our ability to compute without possessing mathematical understanding, AI extends our ability to process information without possessing genuine cognition. For this reason, AI should not be placed in the same level within the spectrum of intelligence, but rather understood as a tool that reflects and extends human intelligence.
This is for round 6, presenting an argument based on position B. The correct opinion that AI relies on patterns, not a true causal reasoning. A fundamental difference between a human intelligence and artificial intelligence lies in how they understand the world. Human intelligence is not only about recognizing patterns, it is about understanding causality, the ability to reason about why things happen, not just what is happening. Humans build internal models of the world that allow them to explain events, predict outcomes, and imagine new possibilities. This kind of reasoning is flexible, overlooking, and grounded in understanding of cause and effect. An AI system, on the other hand, they primarily operate through pattern recognition and statistical prediction. They analyze large amounts of data that are given to them, and they identify correlations, but they do not truly understand the underlying causes behind those patterns that they are given. The research highlights that AI systems are largely data-driven and backward-looking. They rely on past observations rather than a genuine causal reasoning or a theoretical understanding. This means that even when AI produces a correct answer, it does so without understanding why those answers are correct. This limitation becomes critical in complex or novel situations. Humans can generalize knowledge, form explanations, and adapt to entirely new contexts by reasoning about causes. AI, however, struggles when patterns change or when it encounters situations outside the training data that is given. Without that causal understanding, it cannot truly reason. It can only approximate based on previous examples that are given. In addition, human intelligence is capable of generating new knowledge and an original explanation, not just recombining existing information from all the large amounts of data that is given to them. AI systems are largely imitative. They produce outputs based on patterns that they learn from data that are given, rather than creating a genuinely new conceptual understanding based on it. This reinforces the idea that an AI does not think in the same way a human does. It predicts from all the data that is given to it rather than understands. In conclusion, intelligence is not just about producing accurate outputs. It requires an understanding of cause and explanation and reason, because the AIs currently lack a true causal understanding and they instead rely on statistical patterns. It cannot be considered a human intelligence. It is a powerful predictive system, but it is not a thinking mind like a human's.
This argument draws a sharp line between pattern recognition and causal reasoning, but that distinction is overstated. First, causal reasoning itself is often learned from patterns. Humans infer cause and effect by observing regularities in the world, performing models based on repeated experience. AI systems do something similar. They build internal representations that allow them to predict, plan, and act. The difference is in mechanism, not in the presence of reasoning. Second, modern AI is not limited to simple pattern matching. There is not expensive work in causal modeling, reinforcement learning, and planning systems that explicitly encode cause-effect relationships and allow systems to simulate outcomes and make decisions based on them. These are systems that do not memorize. They evaluate actions and consequences. Third, the claim that AI cannot generalize is increasingly outdated. Many AI systems successfully transfer knowledge across many domains, solve novel problems, and generate new solutions that are not explicitly present in their training data.
At the end of this debate, it becomes clear that both sides are not simply disagreeing about artificial intelligence itself, about what we mean by artificial intelligence and intelligence.
On one hand, position A has shown that if we define artificial intelligence and intelligence itself in terms like the ability to learn, adapt, solve problems, and make decisions, then artificial intelligence undeniably meets those criteria. Artificial intelligence performs tasks, improves with experience, and in many areas even surpasses human capability. From this perspective, artificial intelligence and intelligence itself are about what a system can do, not what it is made of.
On the other hand, position B, we have argued that this position is incomplete. Artificial intelligence and human intelligence, in the sense, are not just about what a system can do. They involve understanding, meaning, intentionality, autonomy, and experience. Artificial intelligence may produce answers, but it does not know why they are correct or even if they are. It does not form its goals, the experience aware, or possess awareness. From this perspective, artificial intelligence and intelligence are not about what a system can do, they're also about what is going on inside the system.
Artificial intelligence successfully replicates many external features of artificial intelligence and intelligence, but it lacks the several internal qualities associated with human cognition and thinking. So the real conclusion is not that one side is entirely right and the other is wrong. Instead, the debate shows that artificial intelligence and intelligence are not concepts. They have dimensions. A functional dimension, which includes learning, adapting, and problem solving, and a cognitive dimension, which includes understanding, awareness, and intentionality.
In conclusion, this debate is not about whether artificial intelligence is intelligent or not, but about what kind of artificial intelligence and intelligence we are willing to recognize and how far we are willing to extend the definition of artificial intelligence and intelligence itself.